Welcome to today's tutorial on the minimum operations for equal subarray sums problem. This problem is an interesting coding challenge that involves arrays, circular subarrays, and optimizing operations. Let's dive into the problem statement and understand what we need to solve. The problem statement is as follows. Given a zero-indexed integer array ARR and an integer k. The array arranged by is circular. Your task is to return the minimum number of operations needed to make the sum of each subarray of length k equal. In each operation, you can pick any element from arranged by and increase or decrease it by 1. The key insight in this problem is that we can focus on smaller sets of elements that belong to the same position in different subarrays of length k. To determine the size of these groups, we compute the greatest common divisor, GCD, of n, array length, and k, subarray length. Let's look at a couple of examples to better understand the problem and the solution. Example 1. Suppose we have an input array ARR equals 1, 4, 1, 3, and k equals 2. The output should be 1. We can perform one operation on the element at index 1 to change its value to 3. The updated array will be 1, 3, 1, 3. And now all subarrays of length 2 have equal sums, which is 4. Example 2. In this case, the input array is ARR equals 2, 5, 5, 7, and k equals 3. The output should be 5. To achieve equal subarray sums, we can do 3 operations on the element at index 0 to make its value equal to 5 and 2 operations on the element at index 3 to make its value equal to 5. The updated array will be 5, 5, 5, 5, and all subarrays of length 3 have an equal sum of 15. These examples illustrate how our solution helps us find the minimum number of operations needed to make the sum of all subarrays of length k equal. The key insight in this problem is that we can focus on smaller sets of elements that belong to the same position in different subarrays of length k. To determine the size of these groups, we compute the greatest common divisor, GCD, of n, array length, and k, subarray length. For each GCD group, we compute the median of the elements within the group. The median minimizes the sum of the absolute differences between the elements and the chosen value. By minimizing the sum of absolute differences, we ensure that the number of operations needed to equalize the sum of subarrays is minimized. The algorithm involves looping through the range of GCD values, creating a list of elements for each GCD group, sorting the list, finding the median, calculating the sum of absolute differences, and adding the sum to the total number of operations. Finally, we return the total number of operations as the result. Here's the Python implementation of the algorithm. In conclusion, this problem demonstrates the importance of understanding the properties of circular arrays and exploiting key insights like computing the GCD and using the median to minimize operations. Thank you for watching this tutorial.